All right, welcome to lesson 5.1, graphs of reciprocal functions. So we just finished up the investigation, and if you didn't watch that video, make sure you go back and do that. For our learning goal here, we are still looking at properties of linear and quadratic functions. And we're sketching the related reciprocal of those graphs. So here for my f at x, this would be the linear or the quadratic. And notice that for this one, we are only looking at reciprocals. Now, reciprocal means that I'm going to have a 1 on top, right, as my numerator, and then the denominator will be the linear or the quadratic. So today's lesson is only a 1 on top. In our next lesson, 5.2, we're going to put some algebra or some different things in the numerator. So that's going to change the rules. If we're talking about a linear or quadratic, the x-intercepts of the original graph will turn into the vertical asymptotes on the reciprocal. All right, and then the positive y values, we saw that those actually stayed the same, right? They also stayed positive y values. It's important to know what switches and what stays the same. The negative y values also staying the same. The intervals of increase and decrease. This was one of the switches, right? So intervals of increase become intervals of decrease. And then our intervals of decrease become intervals of increase. All right, local minimums. What we saw with our local minimum on our last example was that it became a local maximum. It wasn't the maximum on the entire reciprocal graph, but locally it was in the immediate vicinity. Vice versa, if you started with a local maximum, we didn't take a look at an example of this yet, but it would turn into a local minimum. All right, and then we talked really quickly about what happens when I have a really small y value, when it's really, really close to 0. Well, then when I take the reciprocal, it's going to be very far from 0. Some big y values. And those usually end up being like close to our vertical asymptotes. And when I start really far from 0, what I end up with is being really close to 0. And this means that I'm going to be really close to my horizontal asymptote. All right, so when will the graphs intersect each other? When are they going to cross each other? Well, that's going to happen when the y value is 1 or when the y value is -1. And then for reciprocal functions, there's always going to be a horizontal asymptote at y equals 0. So that asymptote's not going to move for our reciprocal functions that we're looking at. You might remember from grade 11 that if you were to do transformations on a reciprocal function, then the asymptote would move. But we're not going to be looking at transformations of these reciprocal functions this year. All right, example 1. For our first example here, we're going to state the x-intercepts, the positive and negative intervals, and the increasing and decreasing intervals, and where y equals 1 and -1. So first of all, our x-intercepts. So where is this going to equal 0 is basically what we're asking, right? For our x-intercept, we set y equal to 0, and then we get 0 is 5 minus x, and that tells us that x is going to be 5. For that one's nice and simple, you might be able to just see that the x value would be 5. And at any point, you can sketch the graph of this if it helps you. Like me personally, I would rather sketch the graph of this to come up with these intervals, but it's up to you what you want to do. To remember to graph this guy, when we graph y equals mx plus b, we always start with the b value. That's our y-intercept, and then we use the slope to help us count. So on this function that we're given here, it's just in opposite order. They've got the x term second. The b value is coming first, it's 5, and the m value is -1. It's the coefficient or the multiplier in front of the x. So I can see here that I'm going to start this graph. I'm going to start my original graph at 5. And then my slope is going to be rise 1, run 1, but it's going down. It's a negative. And so there's my points, and then I can use my straight line tool or my ruler to connect those. All right. And for some questions, you'll actually be given the graph and you'll just be asked to add the reciprocal to the grid. You won't be given an equation. So watch out for that kind of example. All right, next up, we've got our x-intercepts. We need our positive and negative intervals. And so this is where I think it's a lot easier. Now I can see that the graph is positive or above the x-axis. The y values are positive when x is less than 5. The graph is negative or below the x-axis. That means the y values are negative when x is greater than 5. Right? And I'm not seeing an equal to here because at 5, I'm not positive or negative. And then next it's asked me for the increasing intervals. Well, they did ask me for intervals here, sorry. So I'm just going to change this really quickly to interval notation to remind us of interval notation. And again, I'm using round brackets on both because I'm not including, you can't include infinity and you can't include that value 5 because it doesn't actually have a positive or a negative sign. Okay, and then I'm increasing on, oh actually on this graph I'm not increasing anywhere. There are no increasing intervals. On this graph I am decreasing on the entire domain. And again, they did ask me for an interval. All right, the last thing that it's asking for in part A, we're still in part A, says where is y equal 1 and where does y equal negative 1? So I'm looking at where is y 1 and where is y negative 1, and I can see that these are the 2 points on my graph. So y equals 1 when x equals 4, and y equals negative 1 when x equals 6. So I've got all of that. Now I need to state the equation of the reciprocal. So I'm going to call it g at x, and we'll make it 1 over 5 minus x. And then I'm going to sketch the graph of f at x and its reciprocal. So I've already got the first sketch done for C. This is part C. I just need to label that graph. This is f at x. And then we're going to graph g at x. I'm going to just use the properties that I already had. I know that the x-intercept turns into a vertical asymptote. So grabbing my straight line tool, I'm going to throw vertical asymptote, and it's going to pass through the x-intercept of the original. Then I know that my graph does go through 1 and negative 1 here. I also know, I've used my straight line tool again, that there's a horizontal asymptote here at y equals 0. I know that my graph should be above the x-axis where my old graph was above the x-axis. And here this graph, the red graph, was always decreasing. So my blue graph should be always increasing. So I'm going to try my best with my tablet here. Oof. We'll do it in smaller sections. So I'm increasing, and along here there's the left section of my graph, and then over here I'm also increasing. The original graph was decreasing. All right, moving on. That was g at x. Moving on to the second equation. Again, we're going to go through the same things here. I want to know the x-intercepts of this original function. We're starting with a parabola this time. For my x-intercepts, I'm going to let y equal 0. Remember that when you take this squaring over to the other side, you have to do the plus and the minus square root. So now I have plus or minus 1, and I've got that negative 2. I'm going to bring it over and add it to the other side. So I can see here that x is either going to be 2 plus 1 or 2 minus 1, so 1 or 3. So I've got two x-intercepts, and there are other ways. Maybe you just chose to graph the parabola first. That's fine as well. To graph this parabola, maybe you remember that the vertex is going to be, because this is in vertex form, the vertex is going to be at positive 2 and positive 1. So positive 2 and positive 1, there's my vertex. This parabola opens down because of the negative up here in front. And the a value is 1. So for those of you who use a step pattern, the step pattern is going to be over 1, and because of the negative, it's down 1. And then from there, so I'm going to go from my vertex over 1, down 1. And then the next step is going to be over 1, down 3. So starting where I left off, I'm going to go over 1, down 3, and then my next step is over 1, down 5. So again, starting where I left off and down 5 squares. And then I just repeat the same pattern on the other side. And hopefully this lines up with what I found before. My x-intercepts are at 1 and 3, and that worked out. So now I'm going to add my graph. All right, there is f at x. So now we're going to worry about the rest of the questions they asked me about were the positive and the negative intervals. I can see that this graph is positive or above the x-axis between 1 and 3. And it's negative from negative infinity to 1 and from 3 to infinity. And then I can take a look for the increasing and the decreasing intervals. This is a parabola, so I'm going to have both. This graph is increasing from the start, so from negative infinity all the way until I hit the vertex at x equals 2. And you can put the x in if you want in the front here. And then it's also decreasing after the vertex, so from x equals 2 until x is infinity. So I'm always talking about the x values for my increasing and my decreasing intervals. And same thing here, you can put the x in if you want in front here. We are talking about x values. All right, we need to figure out, well, what are the points where y is equal to 1 and y is equal to negative 1. So I'm looking on my graph at y equals 1 and y equals negative 1. So across from 1, I can see that the x value is 2. So the points that I'm interested in are 2, 1. And the next points that I'm interested in, I actually can't really tell where they are. So to figure that out, I would have to use the equation. So I'm going to run out of space here, but that's okay. I'm going to plug in negative 1 for my y value. And then I'm just going to rearrange this. I'm bringing the positive 1 here over. It's going to become negative 2. And then I'm going to divide out that negative. So it's going to become positive 2 is x minus 2 squared. Then I have to do the plus or the minus square root. And then finally I'm going to bring that 2 over. It was subtracting 2, so I'll bring it over and I'll add the 2. So I get two values here. I know that y equals negative 1 when, so y equals negative 1 when x is equal to one of these guys. So I'm just going to kind of circle that. There's my statement. And I'm just going to mark these points on the graph because I know that they're important. So here they are, here they are. And you could type these into your, like this 2 plus root 2 and 2 minus root 2. You can type that into your calculator and get a decimal equivalent just to check, and hopefully it ends up around these values on the graph. All right, now we are going to work on our reciprocal function. So the first thing that they asked me to do was state the equation. So I'm going to call it g at x again, and it's just going to be 1 over my original function. To come up with this equation, I'm going to grab my line tool first. I know that for a reciprocal function, the horizontal asymptote is always on the x-axis, and then my vertical asymptotes are going to be wherever the x-intercepts were. So there's the first one, and there's the second one. So what does this function look like? Well, this local maximum on my original function is now going to be a local minimum. The height of the minimum, so the x value is going to stay the same, it's going to be at x equals 2. The height of the minimum is going to be the reciprocal of the old y value. Now the old y value is 1, and the reciprocal of that is 1 over 1. So it's actually not going to move in this case. Now, it used to be a maximum, now it's a minimum. So now it's going to actually open up. And this makes sense to us, hopefully, that all those intervals of increase are flipping to intervals of decrease. So on my original, I was increasing, then decreasing, and now my reciprocal, I'm decreasing and then increasing. I also noticed that when my red graph was really close to the x-axis, my blue graph is really far from the x-axis. That makes sense to me. All right, now the left chunk, this is kind of looking more like our regular reciprocal. So I do have to pass through this point, and then I'm going to get closer to my vertical asymptote here, and then closer to my horizontal asymptote over here. And then same thing on the other side over here. And I should see all of my intervals of increase and decrease are flipping, but anywhere that my graph used to be above the x-axis, my new graph is above. Anywhere that it used to be below, my new graph is below. So here I've got my g at x graph. And I believe these grids actually didn't come with the y and the x on them, so make sure you add that. All right, our next example, we're looking at x squared plus 2. So this guy's a little bit different. This is just a parabola with a vertical shift up 2. So hopefully you recognize that. When I think about x-intercepts here, this is never going to equal 0. Thinking about making this equation equal to 0, if I take a number and I square it, it's going to be positive or 0 at the very smallest, and then I'm adding 2. So this will never equal 0. Or you can be thinking about that parabola shifting up 2. The next thing, so there are no x-intercepts. The next thing that it's asking me about are those intervals. So I'm going to use the graph to help me with this. This is just my parabola shifted up 2 units, and then it's got a regular step pattern, so that tells me to go over 1. That's 2 squares on this grid, and up 1. Over 1, up 1. And I've stretched this out on purpose so that you can kind of see what's going to happen. There's going to be something really small happening down here at the bottom. So if I went over 1 again, I'd have to go up 3, which is going to be way off my grid. So just making sure that when I draw this, I'm not crossing over that 2 line, because I know that that's going to happen after I leave the grid. All right, there's my f at x. So talking about positive and negative intervals, this graph is positive on the entire domain. It's increasing after the vertex, and it's decreasing before. And again, you can include the x is in if you like. Next, we need the y. Where is y equal to -1 and +1? And on this graph, actually, there's no graph across from 1 or -1. So y does not equal plus or -1 for f at x. All right, now we are going to sketch the graph of the reciprocal. So we don't actually have any clear points on this one because there's no points across from 1 or -1. There's no vertical asymptotes for me to add in, but I can add in that horizontal asymptote. This is normally what we start with, right? Asymptotes and the points across from 1 and -1. So now we're kind of stuck. The next thing that we know is that the old minimum is the new maximum. So the old minimum was at x equals 0, so the new maximum will be at x equals 0, but we need to figure out the height of it. So the height used to be 2, it's going to be the reciprocal then of 2. So it's going to be at a height of 1/2. I'm going to mark that really clearly so that my teacher can see that I understand things. For the next points, you can plot some more clear points. It's going to be the reciprocal of the height, remember? So the x value is not changing. Just taking the reciprocal of 3 would be 1/3. So I would have like a height here of 1/3. And then that's going to continue, and they're going to continue to get smaller and smaller, right? As those y values on the original get bigger. And so what happens, this kind of looks like this. It's just like this little tiny blip. And if you look at this on Desmos, you probably wouldn't even see the blip because their y-axis scale would be squished together a bit more, and the blip would keep squishing down as it did that. But I do want to see it, so you've got to make sure that you make it nice and stretched. Some of the answers in the homework also, you won't be able to see the blip, but you can always zoom in on Desmos to check your work. And of course we need to come up with the equation for this. It's just 1 over the original equation. That was our part B. All right, last example, we want to see, well, what happens? This guy's another special case for a parabola. There was 3 different kind of things that can happen with a parabola. This is the third thing. When I look at this guy, first of all, I'm going to be thinking about, well, where are my x-intercepts? And so what is going to make this guy equal to 0? When I move over the squaring, I get the positive and the negative square root of 0. Well, they're both 0. And then I just bring over the 4. And so it says that I'm actually only going to have one x-intercept, which is odd for a parabola, but this makes sense. If I think about the transformations of this parabola, there's no c value at the end, so there's no vertical transformation, or translation, sorry. And then there's no a value out front, so there's no stretch or compression. This has just been shifted 4 units to the left. So there's my parabola, and then from there it's just the regular step pattern, over 1 up 1, over 1 up 3, over 1 up 5. And then I repeat on the other side. All right, so what do we need to know? This is our x-intercept. I'm just going to label it. So where are we positive? We are positive on the entire domain except for at x is -4. That's not positive or negative. So we're positive from -infinity to -4, and then again from -4 to positive infinity. And we are negative nowhere. So next we are increasing. We're increasing after we pass over the vertex. And we're decreasing before we get to the vertex. All right, where is y equal to 1 or -1? So I'm looking, oops, at 1 or at -1. So I can see that there's no points across from -1, but we've got 2 values and they are really clear to see from my graphing. So I'm just going to grab them from there. I'm going to have shared points then. At -5, 1, and at -3, 1. So I can mark those right away on my g at x graph. Got those marked. I can also add in my asymptotes. I know that there's going to be a horizontal asymptote since this is a reciprocal function, and I know that there's going to be a vertical asymptote where there's an x-intercept. So this is kind of strange for us. We've got that vertical asymptote just once. It's kind of more like a line. But this one's a little bit different because remember, with a straight line, I would have been partially below the x-axis, oops, and partially above the x-axis. But in this case, I'm always above. And remember, our properties tell me that if I was started above, your new graph will also be above. And that's what happens here. I end up with both sections of my reciprocal graph above the x-axis. And that's kind of our third case for what can the parabola turn into. There was this case here with 2 sections above. There was this case here, which some people call a pimple graph. It's got that little blip. And that can happen above or below the x-axis. And then there's this one here where I've got the 3 sections of my graph. And that's more of our typical parabola. All right, have fun with your homework.